start talking about quadratic functions. And remember that the highest exponent in a quadratic function would be 2. So you have something raised to the second power. So something like x squared plus 4x plus 8. This would be an example of a quadratic function because the highest term is the squared term. When we're talking about quadratic functions, we need to know that they're nonlinear, so they are not a straight line. And they are written in the form of ax squared plus bx plus c. This should look familiar to you because just in the last chapter we were working with factoring those. And this is called the standard form of a quadratic function. We call the shape of a quadratic function a parabola. Okay? Parabola is this curve right here. This blue line is an example of a parabola. They are symmetric around a central line called the axis of symmetry. This red line would be the axis of symmetry. If you think about it, since it's symmetrical on either side of the line, if I were to fold my paper along this line, each side of this graph would match up with the other side. That's what being symmetrical is. It's like a mirror image. So if this line was looking in the mirror, it would see the exact same thing in the mirror. And that axis of symmetry always goes through the vertex, which is either going to be your highest point or the lowest point of your parabola. Now, the parent function is called x squared. That means every graph we have of a parabola or of a quadratic function is going to look like the graph of x squared. So they're going to be either a u or an upside down u. So every graph will either look like a u or an upside down u. It will look like one of those two things. Okay? Now obviously some may open more, some may be steep, but they're all going to be similar to that shape. That's why we have this parent function. And then this is important to be able to compute, the axis of symmetry. And you might not be able to see it here, but this should be a negative b. So it's x equals negative b over 2a. That's how you find your axis of symmetry. And then your y-intercept is always c. It's just your constant. And then we have two different situations. We have opening up and opening down. Opening up is when a is greater than 0. So when your first term is positive, you open up, and then your lowest point will be a minimum. That makes sense. If this graph is opening up, the lowest point would be the minimum. There wouldn't be a maximum because it keeps going up and up forever. And when a is less than 0, the graph opens downward. Then the highest point is called a maximum, and you don't have a minimum when the graph goes down because it just keeps going down forever. So when we want to look at a graph, we're going to first use a table of values to graph y equals 3x squared plus 6x minus 4, and we're going to state the domain and the range. So I'm just going to pick a few numbers, and I'm going to pick ones that I know will work. I'm going to do -1, 0, 1, -1, and -2. And I'm going to plug those in for x. And I'm not going to bother showing all the work on how to plug these numbers in for x for each one. I'm just going to do it one time, and hopefully it makes sense. So I'd have y equals 3, plug in -1 for x squared, plus 6 times -1 minus 4. Then I just simplify. 3, -1 squared is just 1. 6 times -1 is -6, minus 4. 3 times 1 is 3. And I get 3 minus 6 minus 4. 3 minus 6 is -3. -3 minus 4 is -7. Okay? This is kind of the strategy for going through to find out what these points are. So when x is -1, y is -7. And then obviously, when you go to find these other points, you plug in different values for x. And I'm just going to tell you what you would get there. When you plug in 0 for x, you would get y is -4. When you get 1 for x, you would get y is 5. -1 for x, you would get y is -4. -2 for x, you would get 5 for y. So when I plot these points, I have -1, -7. I have 0, -4. I have -1, -4. I have 1, 5. And I have -2, 5. Sorry, this should be -3. -3, 5. And you notice, when I actually sketch in the graph of my function, it's going to be opening upward. It's going to be a parabola. Okay, it's a parabola because it's this curved line. Hopefully yours looks a little better on your paper than mine does. Okay, but that's all we're doing. We're just graphing a parabola. This is what a quadratic function will look like. It will always be either a u, or if this had been negative, if a had been negative, it would be opening the other way and go upside down.